Okay, the purpose of this podcast is to demonstrate the use of the TI84 calculator when doing calculations for permutations and combinations. And so what you see on the right hand side are some examples, three different kinds of examples. The first one involving arrangements or permutations. The second one also involving permutations, where we select a certain number of people from the group and then arrange them in order. And the third example involves combinations, and the purpose will be to show you how to evaluate these on the TI. Okay, and so what we'll do is begin with the first example, and what we're talking about in this case is a permutation where all 5 of the people are going to be arranged in a line, and so order matters. In this particular case, what we're interested in is the formula n factorial, and in this particular case our value is 5 factorial, which is by definition 5 by 4 by 3 by 2 by 1, and that will yield the numerical value of the number of arrangements that are possible if 5 people stand in a line. I'm going to do is come across to the calculator and show you how it is you would evaluate this on the calculator. And so what we're going to do is select math, and I'm going to scroll to the left because it's a bit quicker. I'm interested in the PRB, the probability menu, and what I'm interested in is number 4. Okay, and so before I do that, what I do is I type the number in this particular case it's 5, and then I'm going to go across to math and probability, and I'm going to select number 4, 5 factorial, and hit enter, and that will evaluate 5 factorial for us. And in this case we can see that the answer is 120. There are 120 distinct arrangements of 5 people standing in a line. Okay, for the second example, what we're doing is evaluating a permutation, and so it is the number of different permutations of 3 people selected from a group of 5. And so in terms of the notation, we are writing 5p3, which is going to be the number of arrangements of 3 people selected from a group of 5 where order matters. This translates mathematically as 5 factorial divided by, in this case, 5 minus 3 factorial. The notation officially for permutations, if we had n p r, where r represents the number selected, then the formula would be n factorial divided by n minus r factorial. Okay, and so in this case, as is clear, we could in fact use the factorial notation. This would be a little more time consuming, and so what we're going to do on the calculator is, and again, we're going to start on the calculator by typing the number 5, then we're going to go into the math probability menu, and you'll see the second one, NPR, we've typed in n, the total number of people, and so we're going to select NPR, 5 NPR, and in this case it's the number of permutations of 3 people selected from the group of 5, which will yield the value of 60. And you'll notice, of course, that the value is smaller than the answer obtained in the first one, and that is because by selecting only 3 of the people, we are reducing the sample space, the number of distinct possible arrangements that are possible. Okay, and then to the third one, what we're dealing with in this particular case is a combination. And effectively, when we move from permutation to a combination, we are moving to an instance where order does not matter. And so it simply involves all the different possible selections of 3 people out of 5 all the different possible combinations that we could get. And again, the key word is distinct combinations. And so what we're going to do again, notation wise, in general terms, it would read NCR, which would be the number of combination, C representing combination. We would select R people out of N, and it would yield the number of combinations. In general terms again, the formula is n factorial over n minus r factorial r factorial. In our specific example, we are talking about the selection of 3 people from a group of 5, and once again we'll use the TI calculator to make the calculation efficient. And so 5, we go into the math menu, scroll to the left, probability. We're now interested in the third option, which is NCR, number of combinations, and we will type in 3. We're selecting a group of 3, and once again the number gets smaller, and that is because we are reducing sample space once again, because order no longer matters, and so the order in which they're picked is not distinguishable, or is not an issue, and therefore the number of different combinations or arrangements is reduced. And that is all.